Yep.
All right. Good morning, everyone. I'm just dealing with a little bit of the time lag between live and almost live, right? Welcome to the Future of Transportation and Mobility Conference, the third annual conference, this time brought to you virtually. There's over 300 of you registered. Thank you for the enthusiasm and attendance. My name is Richard Dunda. I am the director at the Center for Integrated Transportation and Mobility, which is housed at the Innovation Factory Incubator Center in Hamilton, Ontario. I'd like to introduce my partner in crime in producing and developing this conference, Chris Gillis from the Oshawa RTDS. Chris?
Great. Thanks very much, Richard. Pleasure to be here. And I guess one of the key things about this, as Richard alluded to, is this is a collaborative event, and between the Hamilton RTDS and the Durham RTDS, which are the regional technology development sites, part of the AVEN network. And really, on behalf of Durham, I just want to say that I'm really excited to be part of all of this. I think Richard and I were just saying our teams have been collaborating since November, really, on all of this, and we've really got a great lineup of speakers and topics. And maybe for those of you who don't know about or not familiar with the Durham RTDS, it's a partnership between the Spark Centre, Ontario Tech University, Durham College, and Ontario Centre of Innovation. And we have a theme for our RTDS of the human-machine interface, which is basically the infrastructure operating system for connected and autonomous vehicles. If those people are looking to work with us, we've got the ACE Centre at the Ontario Tech University, which is the only climactically controlled aerodynamic wind tunnel in the world, which is a pretty amazing facility and has a variety of other test beds for structural integrity. We have the Spark Centre, which is, of course, the Regional Innovation Centre, which can provide commercialization services to innovative tech-based entrepreneurs, and the college, Durham College, and we focus on sort of the community readiness aspect of things. And we can provide support for technology development in the cybersecurity, artificial intelligence, mixed reality, and augmented reality projects. So, Richard, I'm going to hand it back over to you.
Thanks, Chris. Just a little more about AVEN. So AVEN is the Autonomous Vehicle Innovation Network, for those of you that don't know, in Ontario, funded by the province of Ontario, right, to drive innovation in the auto sector. And as we've learned through integration with connected and autonomous vehicles, that often ends up with innovation in smart cities and smart mobility as well. And as Chris mentioned, Hamilton and Oshawa are two of 6 regional technology development sites in the AVEN network. Chris just gave you the description of what Oshawa focuses on. Hamilton focuses on creating smart infrastructure in real city environments, so you can do real world testing, right? And we have an update on that on March the 9th in a special seminar if you're interested. I'll mention that later as well. I'd like to introduce now the director of AVEN, who puts all the program together and herds the cats across the province. The 6 of us that run these regional technology development sites, as well as the demonstration zone in Stratford. So without any further ado, I'd like to introduce you to Rod Kadri. Rod?
Thank you, Richard. And thank you, Chris. It's great to be here. I'm very glad that I've been able to participate again. And I think this is our 3rd annual event put on by the Durham Regional Technology Development Site and the Hamilton Regional Technology Development Site. I'm great that we were able to take it live this year, because this is one of my favorite events to participate in. If we look across the province, we're doing phenomenal things in driving the commercialization of new technology and the growth of homegrown companies and getting them into the global market regionally and then provincially. And it's all thanks to these regional sites where we bring together collaboration in our regions and then tie them across our province through AVEN. And it's thanks to the Ontario government through AVEN that we're able to create these regional sites, support commercialization of technology, which leads to testing and piloting in our regions and helps us with adoption and deployment, as mentioned earlier. And it's great to see that we've got going virtual has not stopped the numbers with 320 people participating. So I'm glad everybody got a chance to participate today. And the agenda looks very exciting, and I look forward to participating in a lot of the items throughout the day. I want to take the opportunity to thank the staff at both regional technology development sites. An event like this is not easy to put together. It takes a lot of hard work, and as both Chris and Richard mentioned, takes a lot of coordination. So thank you all for putting this together, for bringing our regions together, for bringing stakeholders within the regions together and talking about innovation and technology as we drive forward in the future of automotive mobility. And again, just so everybody knows, Ontario is globally recognized as a result of the Government of Ontario's push through AVEN and other activities as a global leader in the future of the automotive mobility sector. And it's thanks to all of you and all of this participation that will continue to push forward in that space. So again, thanks very much for having me. I wish you all the best today and with the agenda and tomorrow and the days after. And I look forward to the great collaborations that will come out of these discussions.
Great. Good. Thanks very much, Rod.
Thanks, Rod.
Okay, just a little bit of housekeeping before we go on with our first speaker. If you have any questions or comments, please feel free to use the chat, right? And our team will field them, and we'll do our best to answer them during the event. If not, we'll get to them after. And you leave them that's in the stage chat. And also, for the first time ever, certainly for this event, but maybe for an AVEN event, this event is actually, in addition to this platform, it's being live streamed on social media. And thank you to Ciclano for supporting us in that. So we're reaching an extended audience with this event. A little bit on today's lineup. Right, so we have some tremendous speakers today. We have Corey Clothier from Stantec Generation AV, who will speak second, right? And a great panel this afternoon hosted by Gatik that'll talk about the state of the art and the state of the industry in connected and autonomous goods movement. And we chose on this for the theme of this conference to focus more about connected and autonomous goods movement than people movement. And our first speaker is from a company called Aurigo, Chris Keith. And Chris's company produces both autonomous vehicles that move people, but more interestingly and topical for this event, they have the Auto Dolly that moves connected, that is autonomously moves cargo around in airport and port environments. So without any further ado, I'd like to introduce Chris, right, who's a vice president at Aurigo.
Hello, thank you, Richard. How you doing?
There you go, Chris. Welcome.
Thanks for having me. I really appreciate it. So, all right, so here we go. My name is Chris Keith, as Richard had said, Vice President of North America for Aurigo. And I'm going to kind of give you a overarching view of what we do and go straight into the cargo side of things, where we're going to take a look at our Auto Dolly and our Auto Sim package and how we can move things across airports specifically in this case. So let's jump right in. All right. Here we go. All right, so hopefully everyone can see this. Okay, so who is Aurigo? We were established in 1993. We're going to be celebrating 28 years this year. We have global offices around the world, as you can see on the slide. And we have a wholly owned developed ACS control system, and we build our own hardware, meaning the vehicle and dollies and control systems. We are a tier 1 automotive supplier to a lot of OEMs, Jaguar Land Rover, Bentley, Aston Martin, name a few. And we're accredited through ISO 262 and all the others. So we have currently 4 products in the hardware side: the AutoPod 4-seater, the 10-seater Auto Shuttle, and the Auto Dolly Auto Patrol, and software Auto Sim and Auto Connect on the software side. So just to give you an idea, if you have not seen it, here is our Auto Shuttle, our AutoPod, and what we're going to talk to more specifically, the Auto Dolly today. Now, what we found when we started going through use cases at the airport, what was the problem? And we were reached out to by British Airways, and some of the things that they wanted to work on were operational efficiencies, things like airplane damage, cargo damage, and safety. So when we talk about the efficiencies, we can essentially create a 70% reduction in when tug drivers are sitting at the terminal waiting for the airplane to come in. And the reason they do that is because when the airplane's at the terminal, it will sit there. And the longer it sits there without being serviced through their window, they get charged, kind of like I guess we'll call it a parking meter. So the longer it's there, the meter goes up and up. So it just keeps, it costs more. That's why everyone's trying to move in and out. So we've been able to increase operational efficiencies using our Auto Dolly from not only people, but the amount of dollies used to operate in that space, storage of these dollies, there's more room available. You can eliminate the tug completely. And so as these things move around, they can also go in their own direction. So instead of being towed into one specific area and then hooked up to other places or to other tugs to go in other terminals, they can just go about their business and head to other terminals. Another thing that we were the actual main reason we got into this was to solve how airplanes are damaged during this process. The biggest problem that the airlines have is the engines to the airplane are damaged as you tow the ULD carriers on the tugs. They sometimes hit them. And in our 10 weeks initial research at Heathrow with British Airways, 2 alone were hit. And of course, you hit an engine, you're putting the plane out of service, the costs. And because of this, at Heathrow, they actually keep 5 airplanes just in the hangars for this exact issue. Cargo damage is also another factor because everyone's in a rush to get it in a timely fashion to each terminal and deliver and get cargo to its next destination. Sometimes they fall off the back as they round corners and different things like that. You damage ULD, you can endanger people's lives, you damage the cargo inside the ULD, and then of course, again, cost, insurance, all these things go up when you lose goods. Into the safety side, you can eliminate, which has happened worldwide at airports throughout, the decades where people are injured and killed from these ULD and dolly configurations as they're towed away, and they're sometimes not seen. And so, we're eliminating that aspect of it as well. So this was our first configuration that we had at Terminal 5. This was, we ran the ULD carrier before it became Auto Dolly. They gave us every aspect of how an airport runs, from a hardware side to operations side, from where they need to be, when they need to be, what airplanes are coming in, food trucks, honey wagons, all this. It's just a big dance, a choreographed dance on the airport tarmac to make sure all this goes off. But there are so many efficiencies I discussed earlier that we began chipping away and solving the problem and created even a better product than we had originally even hoped for. So When we talk about the use case results, what exactly does that mean? So as far as tug drivers, seeing as you're eliminating the tug altogether, you reduce about 78% of the support needed for that tug, because it's in essence removed. We can remove 100% of the tugs and 72% of the dollies used to carry these things, because they're so efficient with scheduling that they don't have to have the amount required, so your costs fall. And then the health and safety issues, not to mention, a lot of these vehicles are diesel, so everything is running on lithium. There's the air quality and all these things from a green standpoint is, unbelievable. So we can utilize the space by reducing the terms of the dollies. At Heathrow, they're not getting any more airport space because obviously land is, it's finite. So we're able to increase the amount of space without increasing the size of the airport available. And we don't have to have manual couplings where, typical train configuration where they're being towed. Once one gets to point, B, it can move to point C without having to wait for, say, the other two or three. So they can move about at their own discretion. So when we look at the market growth for this type of thing, we always talk about the passenger side and where does that lead? Well, the smart airport market is, expected to grow by 30 to 31 billion by 2026, and we're just 5 years off from that. So the business case is there, the cost efficiencies are there, and so we're with the top 200 airports containing 40% of the traffic. Those are the ones that will benefit the most from switching over to automated systems here in the future. And with almost 18,000 airports worldwide, once you start to automate those, your efficiencies, planes are on schedule more often. Packages don't show up late. People get to their destinations on time. All these things ripple throughout the entire industry based off this one little factor. So this is the auto dolly. This is what it looks like. There's a video here I'll show you in a second. It kind of, to me, looks like a nice Tron-esque design. It's as functional as it is beautiful, and you'll see why right here. So this was designed, obviously, per the airport specs and airlines throughout the world. This was the configuration that best suited what they were. And so, super proud of the team with the auto dolly. So, I'm not going to get into too many specifics regarding all the aspects of this vehicle and what it will do. But, automated rollers, lighting systems, all this is done in a new way of, normally you map a system and you have to be on location to implement this type of thing. So we created a way to do it without having to actually be on the ground messing with the operations of an airport, because that's just too intrusive. So as you can see here, there's a little more technical data on batteries and endurance, powertrain speeds, all these things that I don't want to bore you with right at this moment. But as you can see, very robust system, bleeding edge technology. So unloaded, this is what it looks like when it's loaded. It's almost like a piece of art. So your questions about the tech side of things, don't hesitate to throw those in the chat there. But in order to move these things around, it's not just about the vehicle's autonomous. We created a thing called AutoSim, and I spoke to how we didn't want to be intrusive at an airport by, mapping and getting involved with all the stuff, all the operations of the airport that would be considered intrusive. So we created the AutoSim, which allows us to map an airport using existing data off architectural plans, 3D maps. Any new airports are all designed in CAD, like airports in the past. Doesn't matter. We can take this data, everything from food trucks to where they need to be, how many loads they have, honey wagons, where those are, our vehicles with the ULDs, the entire operation of an airport. I mean, literally everything. And we put it specific to each, airport. We build it out. We can create 3D models, and then we can tell you where the efficiencies, how many ULD auto dollies you'll need, how many you won't need, how many tugs will be eliminated. So we can basically go through an entire spreadsheet of cost savings, time benefits, you name it, all cloud-based that the customer can access. And so we can build this and show you before you even have to start implementing. So it's a really, really cool way to do this, manage this type of system in an airport. So that there is, in a nutshell, how the future of cargo will be delivered here in the future. I'm going to get out of the presentation, and then you can fire away with questions. I'll see them come up. Okay, so one of the questions I have here is, would the dolly operate on roadways where aircraft might cross? In essence, like something like this on roadways where aircraft might cross, it depends on what the airport requires. Every airport size and how they handle it is just a little bit different. So if they require a specific use case, we can run through the software and determine if it's something that will benefit them, if it's too much of a stretch in running on roads. But we generally stay in the airport grounds, much the same way the ULDs are now. Wherever they go, we can go. Okay, we got another question here. So the next steps, what are the next steps for a project like this? So we are working with one of the airports we're working with in Singapore, Changi Airport. The next steps in terms of what they wanted to do, we had told them what we could do with the dolly as a hardware piece and how we moved it. And so the first thing they required from us was, hey, can we turn this into, auto sim project and do it without you being here? That was our first test at doing this. And so they, like I said before, they sent us all the data about the airport and how everything operated, from flight schedules to the maintenance schedules to everything else. Put it in the AutoSim, gave them the simulation and how it operated, and they were just, over the moon, I guess you could say, with all the money they were going to save and efficiencies. So that was kind of the next step. So if you were an airport, say, ORD in Chicago or, Miami, you would say, we would like to analyze our efficiencies. You show us what you have now. We'll input that into the system, and we can literally begin to chip away and build from point A to point B on the system, where you stand now and where you can end up. And then we can give you all the data related to, cost savings, to, how many less dollies you'll need, maybe even the vehicles for catering. Maybe we can control efficiencies of where those need to be based on scheduling, that maybe it's not working for you as efficiently as you need to now. So that's that. So how do you communicate with the dollies? Well, the dollies, one of the things that all the vehicles around an airport have, they have GPS tracking. So in essence, you already know where every vehicle is, but The problem with that is you have one dispatcher trying to, orchestrate hundreds of vehicles, sometimes even nearing thousands, at the airport. So it's kind of who screams the loudest, kind of gets the, information first or gets the first priority. So there's a lot of mistakes made that way. And so with our dollies, the communication operates kind of similar using their existing systems, whether it's GPS. Obviously, there's LiDAR and other assets on the vehicle that control its location and real geometry and all these different things. Same as an autonomous vehicle, but a little more fine-tuned for an environment that has a pretty good infrastructure in terms of communication. Well, okay, how are the cans loaded onto the dolly if you have a dolly that fits more than one can, or do you have a dolly that fits no more can? When they come off the airplane, in a wide body, if they're coming off the side or in the back, they're slid off of, as you see the conveyor, and then it goes straight onto the dolly, just like a manual one would be. And as soon as it's in, it's locked into place. And then the vehicle essentially goes green, and it already has its instructions as where to go before even usually the flights come in, because it has an entire log where it records the entire day's worth of data. Now, if there's a change in a flight, it's canceled, doesn't make it in, that can all be sequenced and rearranged, and then I guess we can say the math happens where the algorithms determine what the next best scenario is. But right now it's one CAN or one ULD per your question. So let me see here. As a company that makes autonomous people moving vehicles and good vehicles, can you share the perspective on how those markets are developing? Which market opportunity is more mature and ready for implementation? I would say that the technology is similar with both, but if you want to say more mature, it all depends on where you're deploying. The thing about deploying in an airport, the security is already there. You don't have randomized, people just showing up, in a path like you do with an autonomous vehicle. There's just the general public can mill around wherever there's an autonomous vehicle run. So like if we have our shuttle or our pod in an implement a deployment somewhere, people get curious about, if you jump in front of it, does it stop? What's the, how much stopping distance does it need? People get really curious about that. In an airport, because it's one of the more secure places on the planet, most airports, it is the easier deployment because there's so many set security rules and structure and how the whole airport operates. It's I would say it's an easier deployment. Let's see. How is the maintenance carried out on the dolly? Is maintenance autonomous too? The vehicle can determine with our ECUs that we have built in. There's a set of algorithm software that determines if there's battery issues, if there's different things that are losing their calibration. And I guess the way to describe it in layman's terms is almost like if you're using your PC or Mac and you run a disk utility, and then you can kind of it can recognize what needs to be adjusted back to its original setting, so to speak. So as these things will be used, you can tell where, just like on a computer, do you need an oil change, where's your battery power, is something out of alignment? All those things are factored in because they're squared at 0 when we deploy them, and so we know what variance it is in either direction if it's starting to become uncalibrated, which on something like this doesn't really, you shouldn't have to worry too much about. Battery life uptime during a working day. Now that question depends on airport utilization, size of the airport, distance traveled. So there's a lot of these things, like just like if you had any battery operated anything. The one thing that's great about this is you can get 24-hour operation out of them using opportunistic charging is the term for it, where you can have charging pads or stations. As the vehicle becomes stationary, or say it's waiting at a terminal, it charges on the deck. So wherever it goes, it can find opportunities when it has downtime where it can charge up. So in essence, you can run these 24 hours a day if you need be. I mean, obviously, if it's running nonstop, it's going to require a little more charge time and a switch out. But based on what we've seen at the 3 airports that we're at currently, we can run them 24/7 within the given schedule of the flights at those airports. So let's see. Does the operation of the dolly continue in an indoor setting, or is it strictly just outside? The dolly, and I'd love to show you stuff on the inside, but most airports have, you can't photograph or film in there, it's illegal. But the stuff you've seen with at the Heathrow Terminal 5, it kind of gives you an idea. It can operate in any weather currently that we've thrown at it, and then it can move into the inside of the airport where it is. And essentially what's going off is it knows where it is based on LiDAR, wheel geometry, GPS, all these different things. And as it moves inside, it just transfers data as to if it does lose a GPS, and it has to go strictly with the LiDAR features and wheel geometry. But it can operate in both. We've had some pretty horrendous rain and weather in both Changi and Singapore and Heathrow, and we haven't had any issues yet, mostly because the way we built the sensors and how it operates, it kind of eliminates a lot of those chance weather scenarios. Okay. So do you anticipate any benefits from 5G deployments? Currently, everything we're running is with 5G not being ubiquitous, we've gone with the current systems that we have available. And the benefits using something like this is, you can just move a lot more data. The communication, the latency, and everything that's needed to run these, we can do that now with the current systems. So I'm not worried about that. 5G will just give us many more options down the road if we're trying to add features or data streams, downloading information if there's, everyone's looking for incident reports and things like that. And in order to do that, you've got to download all the things. But because most of it's in the cloud anyways, for operational standpoint, you can monitor that real time, and it creates little addendums to our script if it notices an anomaly or anything like that. So, yeah, I mean, the benefit will be more present when it becomes more ubiquitous, because that's just, there'll be more options that will be available to us. Have you been able to test the functionality in winter conditions? We've done a lot of testing here in Canada. I'm currently in Ottawa, and with our pod, our AutoPod, we've got a lot of information in how it works in winter conditions and ice and all that here. So we've been able to kind of send that back to the home office. That's one of the reasons we came to Canada, is to really be able to test them under all circumstances. And the great thing is with airports, because they are so meticulously maintained to operate airplanes, the snow doesn't pile up like say a road situation here. So you really get a lot of benefits from working in an airport system, because a lot of that stuff is kind of taken care of in essence. Do we have any more questions here? I'm looking for. All right. How long does it start? Okay. How long does it take from when you start to work with an airport through a fully implemented system? And how long does it take for the airports to realize return on investment? Okay, that's kind of a tricky question, because it depends on the size of the airport. It depends on what type of data. If it's a new airport, some of these airports are so high tech, they have information that's already digital in essence, that we can just switch right into the system without having to go from analog to digital, so to speak, with, say, an older airport. So that takes time. So when you want to run an analysis on an airport, depending on the size, I guess I could say, well, probably 1 to 3 months, depending on the size of the airport. If you're going with like an Atlanta airport or maybe Beijing airport, those are so huge and there's so much, it would probably be on the longer end of things. And of course, with time, this actually gets faster the more we do. Return on investment, we've seen, just when we did our first airport, we saw during the first year, just running a minimum amount of the ULD carriers in the system that we have was a $2 million return on investment with a minimal implementation. So I have a bunch of numbers that I could sit here and bore all you with, but reach out to me and I can get very specific, or give me a phone call, and we can really get into the numbers, because it's quite dramatic. I mean, we're talking between a 70 and 75% reduction on that cost alone for ULD carriers and moving baggage, which is an enormous amount. So from day one, you're going to start noticing it. Obviously, when you start pulling ULDs out and putting things into service, it's going to take a little bit to see it, but not long at all. Let's see here. How has COVID affected your work at airports and has increased demand? Very good question. With COVID and airports being at basically their lowest service levels in recent memory, probably since the industry began, this is actually the perfect time to do like an auto sim analysis on an airport and prepare for the future. Because as we roll out of this in about, they say 2023, when everything really gets back to pre-COVID numbers, you're going to see all the stuff that we've been working toward will be absolute 100% operational anywhere in the world at this point, as we've done with the 3 previous ones, and that only gets better, obviously, as any technology improves. But so that's the COVID in a I guess you're going to call it a silver lining sense, because there's a reduction. It gives you the time that you would normally not have, and the ability to maybe do some stuff at the airport that you wouldn't normally have the chance to do. So that. So let's see here. Okay, can the auto dolly be daisy chained? Yes. So daisy chain, in the essence of using a hard drive term on computers, linking them together. We don't have to physically link them together. We created a software system called Swarm, where you can have the lead vehicle, in essence, so with the tug out of it, we can use an ULD as a lead, and the remaining vehicles behind it can follow and daisy chain, if that's the term we want to use here, where they can follow behind the first one, taking orders from the lead vehicle, and then if they need to, as they get to another point, kind of verge off into a different terminal if they want. But yeah, in essence, daisy chain, no physical connection, tight formation, which, and that's another thing about these that are really cool, is with a wide sweeping, when they're being towed, you need to get a turn, you need a wide berth to get around corners and different things. These things can go 90-degree angles, so you can open up a ton of free space with these. You go in and just do a 90. You can't do that on a regular tug. So that's even with the companies building auto tugs, you still have the same problem because you're still towing things. So hardware aside, you're still dealing with that issue. So you can eliminate that altogether. Let's see. Okay. When was your first deployment, and what scale did you deploy? Our first, I don't know what I call deployment, but when we first started out was at Terminal 5 Heathrow, British Airways, IAG. that rolled out, we started replacing a series of, Tug Plus 3, which is the Tug Plus the 3. We replaced that. And from that, we can do one system. We don't have to replace them all. Once we just did the one, we were able to just through, math, I guess, we're able to use that one example and then just repeat it over the airport. We can figure it out. So the one at Changi in Singapore, it's larger. The exact numbers are it's over a dozen, but the same applies to that. Just a mathematical, exponential as we increase it, and then you can kind of get your ROI. AutoSim will give that to you already, but then you do the real world testing. You don't need to do a full deployment in order to figure out the benefits or the utilization aspects of rolling this out. That's kind of the benefit of this. You don't have to drop a ton of money to get into the game, I guess, and then you just build it out as you need. Once you get comfortable with how all this stuff. Because a lot of autonomous vehicles and technology, it's a game changer, and there's some adoption to it. Not that there's any issues with our tech. It's just that some people, there's always going to be slow adopters and there's going to be early adopters. And the early adopters, like in Singapore, they're gangbusters. So we're going to see that jump dramatically. So let's see here. What we got here? The 31 billion estimated market by 2026. Does a regional breakdown exist for North America, Canada? The regional breakdown, I do not know. That's kind of like an overarching number they give you. Worldwide, this is what it's looking like. I guess based on the amount of airport traffic, depends on when people come out of line with COVID. I know we're only doing 4 airports in Canada. But with U.S. and Asia and Europe taking most of that, it just depends on how you break the pie up, I guess. And I do not have those numbers. Is there a Canadian trial, the Auto Dolly, yet? No, I've been in talk with the Ottawa Airport throughout the years, whether it's shuttle or pod, Autopod or Auto Shuttle, for moving pilots and staff around from the parking structures to the airport. But because this is new product, we launched last week. We've been working on it for years now. This is kind of a new thing. And so my intent is, to use Ottawa, Hamilton, Toronto, Pearson, all the airports in Canada, and get them online as fast. And we can do that by, like I said, they give us a call and they say, hey, we'd like to analyze the airport and get it, into AutoSim and look at where our efficiencies and our operations stand at now. And then they can do all the tweaks and start, pulling old dollies out and things out of the equation. And then they can start to see where their numbers lie. And so, anyone wanting to get involved in this, that would be the call, and we'd start it out that way, and then you can just start rolling out hardware soon after. So let's see here. So can you speak towards the next steps or things to come for Arrigo or the Auto Dolly? Arrigo, one of the things that we prided ourselves as a company is, I guess you could say, kind of like in the Apple computer model, we have our own ecosystem, and that allows us to really take advantage of having our software team and our hardware builds. They sit amongst each other. So when there's an issue, or something they want to do, they don't have to go to the manufacturer, so to speak, or have to go to an off-site software team. Our team is all together, and all our technology works seamless together. So we can just move from bit to bit along our ACS and change things. So that's one of the things when you say what's the next step, like that allows us to deploy faster, and because most of the team is from some form of the automotive industry. Not only does it run great, but everything's elegant, it's beautiful, and comfortable for passengers, and it's one of those things that just works. And I'm super proud of the guys and gals for all the stuff they produce. So yeah, that's kind of a little overview of Arrigo and us and logistics. And I hope I didn't talk too fast or not give you enough information, but with time being limited, that's what we're looking at right now. So I appreciate your time and listening to me talk. And so I'm thinking Richard's going to get up here.
All right. Isn't technology wonderful?
Yeah. It's so I hope that was I didn't skip over anything. Maybe leave a plot hole out, or so to speak. So that you didn't understand some of the things that we do. Is there anything specifically that you can think of?
Chris, it was fascinating, and I know sometimes, and I know your company's in the business of both shuttles and now goods movement as well. Sometimes shuttles get all the press, right? And real vehicles that do hard work in constrained environments like airport are ones that are market opportunities faster and sooner, depending on the market you're in, as you said. Right, so it's fascinating to see the auto dolly, and thanks for sharing it with us today. For those of you in the audience, we will make both Chris's contact information available later if you have specific questions to follow up, right? As well as this presentation, and a recording of this presentation will be available through the CITM and Durham RTDS websites following the event. Chris, I wanted to thank you. Great work, great job. I know that we worked together to put this together and make it flow. So thank you for the time and effort putting in. And thank you to the engineers on your team for embedding such a pretty cool product. Any last words that you wanted to share? Or?
Yeah, no, I mean, just seriously, just drop me a line, give me a call. I'm available. I would love to, sing the praises and speak the technology, because it's and we're learning more every day. And the great thing about this world is this is the worst it's ever going to be. It's always with tech, right? It's always going to keep getting better and better and better. And so, the world is going to look dramatically different in the next few years. And I think the cargo side is going to be first. And then as we go, towards the vehicle side and level 5 vehicles, it's super exciting time to be alive.
Yeah, I know that Chris Gillis, who sits in Oshawa, where there's a major goods port, right, marine port, and CITM that sits in Hamilton with a major goods airport, is pretty excited about this concept, and we look forward to getting a Canadian trial underway.
Oh, we can start tomorrow or today, Richard, whatever you want to do.
Okay. All right, Chris, thank you very much.
Yeah, you're so welcome. Take care, everyone.
Okay, bye. Bye now. All right. Everyone, just a reminder again that I think you've seen the flow about how to put questions in the chat now. And if you still have questions on Arrigo and the auto dolly, you can field them and we'll take them and answer them offline. And just a little bit about the rest of the day. We're going to go into our second presenter, Corey Clothier, who is the founder and director of Generation AV from Stantec, a consulting, engineering, and design firm with a large practice in connected and autonomous vehicles. And then we'll do a bit of a video break, show off a couple of a client from CITM and or Durham. And then we'll break into our panel discussion for the last part of the day. We'll have a debate centered around the state of technology and the state of the industry in connected and autonomous goods movement. Okay, with that, I'd like to introduce Corey Clothier. Corey is, as I said, the founder and director of Generation AV from Stantec. That is a specific practice that his company has created around connected and autonomous vehicles and smart city and smart mobility environments. to bring focus to the industry and bring focus to the implementation. Another sign that the technology is nearing maturation, is ready for real-world implementation. So Corey, welcome to the conference, and thank you for coming.
Dave, thank you. How's the sound? Good sound check?
Yep, for me
Okay,
anyway.
Good. Good. Well, I don't have an interesting background like you and Chris. I just moved into my new office and there's nothing back there. So unfortunately, everybody just has to look at me for the next 20, 30 minutes. So, but I have a presentation, so we'll have some cool pictures and we'll move through that really quickly. So what I want to talk about, and there was a really good segue that Richard was talking about at the end of Chris's presentation, is that these kind of utility applications for autonomy are really going to come to the market first. And those kind of backstage, non-sexy autonomy is really where I think the highest volume is going to be for the next 5 years. And that's what I'm going to essentially talk about today and present. So let me turn off my camera so I can present full screen. And this may be a challenge because there we go. And it doesn't look like my screen wants to share. So I'll bring my camera back up. I'm trying this again. End up getting nothing. Well, you might just get to hear me talk and not see the cool pictures, unfortunately. Gonna keep trying for just a minute, and then I'll just go and we'll talk about the different applications, which won't be nearly as exciting because I put together really cool pictures for everybody to see. Which is the beauty of doing this in advance, of practice in advance. Yep, and my computer is blocking presentation. Sure. So sorry about that. So let me just start to talk about it. Background, I'll start with my background and then we'll go from there. So I'll do a little storytelling for everybody. So they said, unfortunately, now you're just gonna have to look at me. We'll take it from there. So my background is I've been working in the autonomous vehicle industry since 2009. And I'm sorry, we're just going to do a little admin here. I can email it to our folks and they can pop it up for me while I do my intro. So 1 second, please. Hopefully I'm not losing too many of you. So as I was mentioning, my background, I started in autonomous vehicle strategy as a consultant with the Department of Defense in 2009, the research and development center called TARDEC. And this is based in Michigan and was essentially supporting the R&D strategy for autonomous vehicles. It was really fascinating. They called it ground vehicle robotics in the military. And I worked there for 6.5, 7 years and helped with kind of a universal strategy of what they could invest in, how they could, create interesting strategic relationships and partnerships. And we launched some of the first demonstrations and pilots in the country. So our first pilot was actually at a hospital campus at Fort Bragg, North Carolina. And it took place around 2013, 2015. And I just sent my presentation over. So hopefully we'll be able to get that going. But what we did was, some of the first, as I mentioned, demos and pilots. I also supported the first level 4 autonomous shuttle demonstration at CES in 2014. We launched Las Vegas Shuttle 2018. What else was out there? So I've been around this space for quite a while, and I've also been able to had the pleasure to work in Dubai on their autonomous transit challenge, that was really interesting. Worked in many cities around the U.S. So we're still trying to get that presentation up and running. Did you guys receive my presentation through the email? I'm waiting for the response in the chat. Let me tell you about the theme. My theme today, as I mentioned before, is we're going to talk about these low-speed logistics-based applications. So we're going to talk about campuses, or city applications, delivery, logistics at airports, things like that. What I'd like to share is some of the things that are going on in the world, but it's not a comprehensive view. This is just a snapshot, and hopefully to kind of plant the seed a little bit of where the potential, the potential for autonomy is now, and where we're going, very shortly. And so let me get started. Let me pull it down. So as they're pulling up my presentation, let's talk a little bit about whether or not this is real, and if autonomous vehicles are even ready for deployment today. So Chris gave a really nice talk of what they're doing, and they're essentially proving that there are applications that are real, and the technology is ready for deployment in some areas. So some areas that have been actually deployed for quite a while are agriculture, and we also see deployment in mining quite a bit. And Chantal, I see that you came on the screen. Are you putting the presentation up, it looks like? Okay, excellent. I'll turn off my camera. And we can jump right down to slide 10, if that's okay, Chantal. So I apologize, sorry about that, everybody. That's the value of practice, right? I didn't practice popping up my PowerPoint presentation and got blocked. So these slides that we're skipping past are just some of the projects that I've worked on in the past, but that's not as interesting as what we really want to talk about is the logistics applications. Some of those that are kind of circled in this collage is, we see a UAV delivering packages and a couple small delivery robots. So we can go to the next slide, please. So as I was mentioning before, as we start to think about what's real, we kind of take a look at science fiction. And to me, science fiction plays an interesting role in that it sometimes is very predictive of the future. And, we even think about our smartphones. That was really, 40, 50 years ago in science fiction, that was even beyond their comprehension that we would have this kind of ability to be able to walk around with this computer in our hand that could connect us to the world, and we could do video chats and things like that. So here's a little picture of Pixar's WALL-E and Disney's vision of a utility robot that collects and compresses and stacks trash. I think it's a legitimate application. Hopefully the world won't look like that at any time, but it's an interesting application. And we can go to the next slide. And then here's just a kind of a broader view of, again, from the same movie, WALL-E, but these are all just little utility robots. They clean, they paint, they deliver, and they maintain. And then my question, is this science fiction or is it prediction? We can go to the next one. So these low-speed logistics and delivery autonomous vehicles, are they the next generation of robotic heroes, saving time, money, and even lives? And let you be the judge, but I think my thought on it. And go to the next slide, please. And thank you so much, Chantal, for driving. That's super nice of you. So this is just a quick screenshot from Thor Drive. Thor Drive is, what I'm going to do is just kind of quickly just go through these just to give you a glimpse and hopefully spur discussion, so we can have an interesting discussion on the back end of this. So Thor Drive is creating autonomous solutions in multiple areas. Most of them are around logistics, and they make the bold statement that the future will be automated. It's going to unlock efficiency, reliability, safety, operational excellence, and what's previously unattainable in the business world. And I really think that's interesting in that last statement, that it starts to talk about the economics and the business case. And all of the projects that we work on, and I was a little flustered trying to get my presentation up. I didn't really tell you what I do now. So Stantec Generation AV, what we are here to accelerate the planning, the deployment, and the adoption of autonomous vehicles. So we're a consulting firm, but we are creating the tools to help enable deployment of the autonomous vehicles. So I think it's our way of making sure that all of the proper planning and the support work and safety evaluation and risk mitigation and all of that great stuff is done. It's all that backstage stuff that's necessary to ensure proper, reliable, and safe deployment. So that's kind of in a nutshell what we do. We have a robust team of, I think, world thought leaders and world leaders with experience in autonomous vehicles. I think we've got people that have created the standards for safety in autonomous vehicles, some of the top engineers that have worked in deployment, more deployments than I think anybody else in the world. And we've worked with great companies like Arrigo to help with projects and things. I have a couple pictures going forward. So if we can go to the next slide. Let's jump back into airports, as Chris was talking about. So here, what Chris was talking about is his little cart, which I have a picture of a first generation version, is let's think about the business case and the need at airports. ULDs, these unit load devices, they are the leading cause of damage to aircraft, about $400 million a year. And in my notes section, I do supply the references of where I got this data. And there are about 900,000 of these in global circulation every day, just moving throughout the world. And there's an opportunity there for efficiency and safety, as again Chris talked about. So we can go to the next slide. Let's look at what a few different companies are doing in this space and take a look. So we know all about Arrigo now. So this is the earlier generation of their auto dolly. Really fascinating. It's really revolutionizing. I won't go into this too much more because Chris did such a great job. But big fan of these guys. And what I think is really interesting is their take on it of being able to automate the actual dolly gives them more flexibility and more efficiencies. And I think that's really interesting in that these things could be, somebody asked if they could be daisy chained. They absolutely could be for a while, but then they could also break off and go where they need to. That provides more flexibility than a tug, which I think is interesting. But there are folks that are also working on tugs. So we can go to the next slide. And here's Thor Drive again, who provided that quote for us at the beginning. They did a pilot last year with Cincinnati, Northern Kentucky Airport. But you see, here's just another version of autonomous company working on airside equipment. So, used for luggage or ULD transport. We can go to the next one. And I'm gonna start kind of moving through these pretty fast. TLD and Easy Mile teamed up to also to automate a tug. There's, again, same airport applications, but it starts to see, and this again is not a comprehensive view. This is just a snapshot of a few companies. So we can go to the next one. And then you start to think about what else could we do with these tugs? And here's an industrial campus that, again, that Easy Mile with their Tracked Easy product is working with a manufacturing company. And we also start to think about the business case, and they claim that on average, about 18 months to 2 years, you can see a return on investment for this product. And if you think about that, even in these early stages of development and the technology, that you can get ROI that fast, because these are only going to come down in prices as the sensors become less expensive and we start to see more economies of scale. So pretty impressive that we can see an ROI in 24 months in the current technology. We can go to the next one. And another product that is being used actually at airports. This isn't automated, but it gives us a glimpse of it, that it could be automated soon. So this is an electric remote controlled pushback device. It's saving a lot of time and energy and fuel. And we see the little quote that 54% reduction in delays at Heathrow Airport, which is really a major cost savings and economic opportunity when you see those types of savings in time and turnaround of the aircraft. But think about those will be automated one of these days. And the next slide, please. And please, jump in with questions. I'm gonna save some time at the end to answer questions. So I'd love to chat with everybody. But here's another product. This is more an aircraft tug. It's a taxi bot. It could be remote controlled from the cockpit, or it could also be automated at some point. But this is, again, huge cost savings on moving the aircraft from the gate to the runway. So you don't have to burn fuel. You can essentially, you're essentially just burning this electricity in this tug. But they're also finding that there's tremendous, there's advantages in turnaround time. That this can move the aircraft faster and in a more agile way, which again, that's really more of an advantage for the airlines, is turnaround time. We'll go to the next one. Now, to shift gears a little bit, we're going to leave the airport and we're going to start to talk about more consumer-based products that are, we're talking about delivery players. So this will be in the slide. I won't go through all of them. It's kind of an eye chart anyway, but I want to thank my friend, Damien DeClercq from Spring. He's the CEO and founder of the company Spring, and based out of Berlin. And he has autonomous delivery robots. And we'll show a picture of that in just a second. But this is a really nice chart that he put together that kind of shows a snapshot right now of most of the players out there in autonomous delivery. So we can go to the next one. And this is the Spring vehicle. It's actually created by a Chinese company, Neolix. And Damien is deploying these throughout Europe, as I mentioned, based in Berlin. We can go to the next slide. And to give you a sense of what these vehicles can do, this is one of the deployments in China this was shown just a few months ago, is that with a partnership with Kentucky Fried Chicken, is that these little delivery robots kind of created opportunity for less human touch. This was kind of a COVID solution last year, but really interesting. But it's essentially the same automated delivery vehicles as Spring is using in Europe, but shows an interesting use case. We go to the next. And I thought this was really interesting. If you think about Neolix, is just where they're going and how fast they're getting there. They are already in mass production with us. So a lot of people don't realize that there are hundreds, if not thousands, of these vehicles already made. And there's all types of different configurations. We can go to the next. And this is just a little snapshot of their gigafactory where they make these. So they are rolling off the line. We can go to the next. I know I'm working you over, Chantal. I keep saying next. So let's come back to the U.S. That's what's going to happen in the U.S. and in North America. One of the companies that's kind of gotten some good press and they've raised a lot of money is Nuro. So Nuro is doing deliveries primarily in California, in the Silicon Valley, San Francisco Bay Area, but really great company. You can operate in mixed traffic on streets, but great company. And they have, if we're talking about the opportunities, and if this is a real thing, these guys were valued at about $5 billion at the end of last year after this $500 million round was closed. So pretty impressive. We can go to the next. And then we've got the little guys. When I say little guys, not necessarily little companies, but little robots like Starship. Starship is probably has the most robots out there, and they've also hit 1 million autonomous deliveries. So really impressive company, and they're really growing fast. We can go to the next slide that shows a little bit more of a version of where they are with their delivery process. So very interesting. I think, you know, there's so much to look at in this thing. You know, they hit their 1 million at the beginning of this year, but showing what the popular products are for delivery, that's really interesting data. But then also showing the savings in CO2 emissions, very important. And great company on its way for massive growth. But it also shows us that we're ready for this. You know, there's the people and the consumers, they like delivery by robot. I'm really excited to have it in my area. So we can go to the next. And another small robot company is KiwiBot. They've been out deploying. They're a pretty rapid deployment option as well. Great little company. They're also showing a reduction in cost, and they're on a mission to really lower the cost of delivery. You know, right now they claim it's around $5 to $10 per delivery, and their mission is to get the cost of delivery under $1. So you can't beat that. So that's just another advantage of when robots are to scale, we will see, you know, efficiency savings, and we'll see definitely improved safety, but we're all going to see improved economics. And I think that's just an important point to keep reinforcing. That's one of our major goals. We can go to the next slide. We're going to keep talking delivery. Got an interesting little company out of Michigan, Pedestrian, that works both indoors and outdoors. I think their first deployments are in hospitals, doing all kinds of different deliveries within the hospital. I believe that pharmaceuticals, supplies, even food. But we can go to the next slide. And what's kind of interesting about these, and you can click again, I think there's a little bit of mini animation in here, is their prediction of that there's going to be over 300,000 robots in the next 5 years, helper logistics robots. That's pretty interesting. I thought that was really interesting. I appreciated that vision from them. We can go to the next slide. And I just wanted to, and you can click one more time, and wanted just to bring up this. Pedestrian is pretty interesting, and they have kind of two formats. Is they have that little autonomous vehicle in the front there. That's the real autonomy robot, and the thing behind it is essentially a trailer. So for the small indoor deliveries, they just use that front portion. If it's a larger on the street delivery, they can use this whole system. So I think it's pretty interesting. And then they also talk about the cost savings, 25 to 35%, $85,000 per robot in just savings. And they predict, 10 to 20 robots per hospital. That shows the market size, which is pretty massive. Okay, we can go to the next. And we've got some more emerging. These are a couple companies I'm actually working on pilots with for different activities like grocery delivery, food delivery. So EVTS has this full electric connected vehicle. It's a 3-wheeled vehicle. So, it's really legally classified as a motorcycle, but it's a mid-speed vehicle. I think it can go 50 to 60 miles per hour, full electric. They have some really interesting connectivity in it, where you could use, easy integration into fleet management projects and things like that. But they can reconfigure the back end to pretty much be whatever you want. It can be a dump truck, it could be food storage, it could be hot and cold chambers, etc. So really interesting little vehicle. Then Interplay is a new startup, also in Michigan, and they have a number of really interesting things, but I just wanted to give a glimpse of them. They're kind of still in stealth. So, but that configuration is really interesting because the entire kind of back of that robot comes off, and it can be, instead of loading the robot individually with packages, the back end essentially is just removed and replaced. So it's just a different vision and version of it, but Interplay is a really interesting company. Wish I could talk about those guys for an hour. So we can go to the next one. And then we're getting a little bit bigger. I talked about small logistics robots, but we've also got to, let's talk about the larger versions, just because this is going to be a massive adoption and a massive opportunity for autonomy. This is usually beyond the sight of most of us, of what happens in ports and terminals, but they are going automated. And Singapore, it's not the first, but it's going to be one of the most comprehensive autonomous versions of ports and terminals in the world. It's going to be a highly automated port terminal when it's finished. We can go to the next. And those were ABB. And then these are kind of back to some ideas. And this I just found this. There's a reference there. I just thought it was cool because I would love it if my trash cans were automated and could take themselves up to the curb and bring themselves back. But I think it could be a legitimate application. We can go to the next. And this is another just a vision, concept only. Don't imply any affiliation with any companies. It's just it was an idea. Is that just the different ways we could use autonomous platform. The one on the right there is by Pratt & Miller. That's actually not a concept vehicle. That's actually a real vehicle used for the military in multiple ways, both for logistics, but also for targeting exercises. But they can take that robotic platform and turn it into many, many things. So that was just kind of a vision. Could it be a themed vending machine was the concept there. So it's not real. It's just a cool idea. We can go to the next. And I think that wraps it up. Just this is what we do. I mentioned at the beginning, we accelerate automated mobility. We have all of the tools to do that. And there's a list of them, and there's my email if anybody wants to contact me. So we can start with Q&A. So again, I apologize for that slow start. Thank you for the folks facilitating being able to save the day. You guys were awesome. And I'll answer some questions. I'll turn my camera back on. Okay, there we go. All right, how do I see AVs actually rolling out? Well, they are actually rolling out already. They are, like I mentioned at the beginning, they are in mining quite a bit. They're in agriculture. They are being tested and trialed in transit applications, full-size buses, shuttles, and small carts. And then all of these utility projects that I showed, almost all of those are real. I mean, the delivery robots, they're happening. So they're already out there on the streets. It's going to take a while to see full adoption and scale, but there's enough of us working on it where I think we're going to see in the next 5 years, it's not going to be uncommon to see delivery robots on the streets and on the sidewalks. What are my thoughts on the cities need to be doing now to support this type of development and adoption? A great question. Need to create a plan. First of all, we need to confirm that you have the policy in place to be able to facilitate this. You need to create a plan that's affiliated or associated with your master plan. And some people are ready to go now, and we can start the planning for an autonomous vehicle deployment. Others are just learning. So you can train your staff, you can do visioning, and then we can do full road mapping towards deployment. A phased approach is always the best. Let's start small and slow and work our way to the big stuff, because it's also necessary because the technology is not fully ready yet in most cases, at least for not full public deployment on public streets. There are a few companies that are ready, but not many yet, but they will be soon. In the next 2 to 3 years, we're going to see more and more coming online with commercial applications. So anyway, that was a long answer to say what you really need to do is educate your team and start the planning process. Do I think that connected V2X and a lesser extent DSRC will play a role in automated vehicle adoption? Yes, I'm trying to think of the word adoption, but it's a given. Automated, in my opinion, automated vehicles are connected vehicles. So whether it's 5G or DSRC or whatever the solution is, it's an absolute yes. It's essential for the redundant safety system, and it also supports fleet management and human in the loop for remote supervision. The technology for CAVs looks relatively mature. Can you speak to the challenges implementing these products and solutions in real world cities and municipal environments? Yeah, there's a lot of challenges because they're not that mature yet. So what you really have to do is make sure you understand all of the risks and put in the proper safety protocols, safety verifications, and these are all of those kind of things that I've mentioned that are the non-sexy backstage things that are necessary for deployment. You have to understand what the capabilities of the autonomous vehicles are and choose the right applications, and then also look at how we can scale and graduate. So essentially some of these have to be deployed with some level of constraint. Think of it as training wheels, and we can go further and faster as we prove the safety and the reliability. So those are the things that we work on all the time. And some of the challenges are some people deploy the autonomous vehicles in ways that they're just not ready for yet. And some of the companies are to blame on that as well, in this, that, a lot of us who are fans of the technology, sometimes we're moving a little bit fast. And some of the companies that are developers have overpromised in the past, and they didn't quite live up to the promises. And there hasn't been any major safety issues, but there has been efficiency issues and cost issues. So I think just a great planning process is the key. You mentioned one, the Pratt & Miller vehicles being used by the military. How much of a role do you envision playing in military applications? Oh, the military is one of the biggest users. Last year, the company Robotic Research just went public, I think third or fourth quarter of last year, that they've delivered over 100 autonomous trucks to the military. So the military is still going to be one of the front runners in autonomous development and deployment. And then as more and more applications come online, things like transit applications, shared mode transportation applications, utility applications like logistics, inspection, security, all of those will, if they work in a city, they'll likely work on a military base. So there's a lot there. Given the very small payload, do you think sidewalk delivery robots like Starships will actually make a difference, or is it more of a novelty and a gimmick for now? Good question. Great question. I'm not sure if I really know. I think all of these kind of purpose-built vehicles and autonomous vehicles have a place, and we will find out, based on just market demand, what's going to make sense where. So I think they're going to have a place. We'll just see where and how. Maybe those are going to be perfect for college campuses, and that's essentially where they stay. They're college campuses and urban centers, and maybe that's it. But that's okay. There's plenty of those out there. But interesting, good question. Okay, interoperability for these amazing AV technologies offered by different companies. Another great question. We need interoperability from the connected vehicle side for sure. We need to be able to share data. In this new connected environment, when we have different suppliers operating different fleets around the world, these fleets and the humans controlling the fleets need to be able to communicate effectively. So I think that's really important, and that's the key, that we need to make sure that we're working towards that. And I've never seen any pushback. There's never been anybody saying, no, I don't, I'm opposed to that. So I think that's where we're going anyway. It's a very collaborative environment when we're talking about scaling deployment. All right, some experts believe deep learning AI will never be able to reach level 5 autonomy, which is not possible in the real world. Can you please comment on level 5? That's a great question. I don't have a strong opinion about level 5, because I think level 4 gets 95% of the job done, maybe even 99% of the job done. I mean, the level 4 constraints could simply just be speed and geography. And if we have any constraints, then it's level 4. So if I limit the speed of the vehicle to 45 miles per hour, 25 miles per hour because of the environment that it's in, now it's level 4. If I only let it operate in this neighborhood or this downtown area, it's level 4. So won't that cover us in most applications? Full level 5, I want to go from my house in Michigan or Florida, and I want to go to California and just sit back and take naps, that being fully level 5. I think that's going to be possible, but is it going to be considered level 4 or level 5? So I probably didn't give you a great answer, but it's kind of how I feel about it. I think level 4 is going to cover us most of the time, almost all the time. We covered various AV use cases, applications. What's a common and how mature is regulatory framework in the US and Canada? Great question. And I think, how mature is it? We're kind of in our infancy still, in every sense, in the deployment of this technology, the development of the technology, and part of that deployment is regulatory. So we're still very new and young. There's a lot of work to be done. How I would rate the maturity, I'm not really sure. I'm not an expert. What I love is that on our team, we have one of the leading experts in North America, and I lean on him to help us with those conversations and that work. So I'm a business guy and a tech guy, and our regulatory team they're amazing and they keep me informed, but they're really the experts. What, in my view, will be the impact of 5G on the deployment, and which use cases, where does that matter the most? It's going to have pretty big impact. And one, being able to be in a connected environment is critical for safety and just efficient operations. But also 5G is going to enable more data transfer. And the more data that we can use and transfer and evaluate, analyze, the better it's going to be. So it's going to be, I think it's going to be a pretty high impact. More data, the better, right? And more efficient and safer. All right, I appreciate it so much. I think Richard's going to come back, and I think we pulled it off, just thanks to the facilitation team.
Thanks, Corey. And
Hey.
yes, virtual conferences come with a few bumps. I was saying in warm-up this morning to the crew that a week ago my furnace went out, right? And today is the day that they're cutting the ceiling beneath the room that I'm sitting in today. So thankfully,
Wow.
I got a noise canceling microphone, and none of you are hearing that.
Yeah.
So life in
Well
real
done.
time. Right, I just posted it in the chat. I have one question, right? So the technology based on your presentation and all the companies that are playing in this space and bringing products to market and the money that's already been invested behind that, where in your view is there still room for innovation? Where does the technology still need advancement?
Honestly, I mean, this sounds like a lazy answer, but it's really everywhere. I mean, even the things that are ready for commercial deployment, like Chris showed us with the Rego, the improvements are going to continue for the next 20 years at least. I mean, we're going to see nonstop evolution of this type of technology with AI and deep learning, all that great stuff. We're learning more every year. But if we kind of simplify it a little bit and think about, really where the furthest we have to come, and it's probably in those full, almost perceived level 5 applications of that. I have a car in my garage that's fully automated, or there's something that's going to come pick me up and take me around town. That's still a ways away. That's going to take us a while to get there. Maybe 10 years ish, and where there's these smaller like delivery applications, they're ready now.
Okay. All right. And of all the projects that you've worked on, what's been I want to say the most interesting, but I need a better question than that. So like the most challenging in terms of actually getting the technology deployed, right? And what were the biggest barriers in that process? Was it regulatory? Was it mindset? Was it the technology itself?
It's funny. It's mostly, it's typically bureaucracy and the people in the loop. If we really understand the technology and everybody's honest about it, we can deploy the technology the way it was designed, and also make sure that we have the safety protocols and the contingency plans all planned for it. So that's not as challenging as just the humans in the loop. We're the challenges, and then also just perception. So when we look at, like, this wasn't really a challenge in deployment, but it was a challenge in perception. Is that we deployed an autonomous vehicle in downtown Las Vegas, and on the first day, it got backed into by a semi truck and trailer. So it was really interesting. But the headlines read, "Autonomous vehicle crashed in Las Vegas," which really wasn't true. This truck was illegally backing up in a urban street, and the shuttle stopped, and the truck kept backing and it kind of bumped at the corner of the vehicle. Very light, limited damage, but the perception was huge. Should we cancel the project? Is this thing safe? It was just perception. Then it was more than the actual reality.
Yeah, it's as much a change management problem as it is a technology challenge.
Yeah.
All right, so Corey, one last opportunity for you to talk about a little bit of what Generation AV is again, and if somebody's interested, how they engage with that piece of Stantec.
Yeah, I mean, I put my email in the presentation, so you can reach out to me, and I'll probably, we can talk, or I'll probably introduce you to another expert on our team. But what we do is we help plan for and deploy autonomous programs, and we can really speed things up. I think that we're going to be able to take RFIs out of the world when it comes to autonomous vehicles. We have an amazing database, supplier database, that can speed up the whole process, and on and on. So won't go too much into a commercial. I'm proud of what we're building and what we've built, and the team that we've assembled.
Excellent. Well, Corey, I'd like to thank you very much for coming today, right, and persevering through the technical challenges. Much appreciated. Super interesting presentation. Your breadth and scope of this topic on a worldwide basis is incredible. So thanks for joining us here today at the Future of Transportation and Mobility Conference.
Thank you so much. I appreciate it. Thanks
again, Corey.
Bye.
All right, for the audience, we're going to take a little bit of a detour from, not a detour, but because it's planned, but we're going to do a video presentation from a company that works with both the Durham RTDS and CITM in Hamilton, called SmartCone. And you've heard a lot today about how technology deploys, what the infrastructure side of the solution is, where the data comes from, how the stuff works. SmartCone is a Canadian organization that makes smart edge IoT hardware, configurable hardware with various components. And starting later in March, SmartCone technology is being deployed on CITM's urban and office park testbed environments in the city of Hamilton. So they should be up and operating, radar, LiDAR, environmental sensors. So we're going to host a little bit of a video today from SmartCone, and I invite you all to have a look and enjoy.
Well, Keen and Alicia, usually when there's a problem in an area, police have to go out and monitor it. However, this SmartCone technology picks up on data for both drivers and pedestrians, allowing them to keep an eye out without actually having to be there.
This might look like a surveillance camera, but that's not its purpose. The cameras pointed towards St. Paul behind Pierce Middle School help collect data.
The number of vehicles that would go through an intersection, the speed of vehicles, how many pedestrians are going through an intersection.
So the cameras help collect the data. From there, the data feeds to a server. And from there, that data is then sent to the police department.
All those pieces of technology work together in one unit to give us all that data at one time, which is a cost savings for number one, a manpower savings.
Right now, SmartCone is set up at 2 locations. The second is at Nottingham and Kercheval. The SmartCone system can be moved to other intersections, helping reassure people seeing those traffic issues.
And so the feedback we're getting from our residents and customers is that there's been a great change in the pattern of traffic, the speeds, and they feel that the safety for the kids crossing has excelled increasingly.
Next Energy is a nonprofit technology company out of Detroit, helping facilitate between SmartCone and police. I'm told there is a long-term goal to help develop new ways of communicating issues at an intersection to drivers.
In the future, that signal will go to the actual control unit in the vehicle, and it will be seamless, like a machine-to-machine communication.
Now, these cameras can be used as a surveillance system, but at this time, that's not what police are using it for. It's just to monitor the traffic in the area, collect that data, and get a better understanding. Allie Hoxie, 7 Action News.
Awesome. I know at CITM we're pretty excited to have SmartCone technology implemented. Pretty interesting stuff. Made in Canada. It should arrive this week and be implemented. So without further ado, I am going to move on to the panel session of our agenda for today. And I want to thank the panel moderator for today, Mark Petrosoniak, right, who had to fill in at the last minute because his colleague at GADIC fell ill this morning. So Mark, thank you very much for your agility and your willingness to step in kind of at the last minute. Mark is the Senior Manager of Strategy and Operations, Business Operations at GADIC. GADIC is another company that is working both in the United States and Canada on connected and autonomous goods delivery. They use modified versions of off-the-shelf Ford Transit vans, I believe, but Mark can share more in moving that. And they have implementation trials in a couple of locations in the US. And for those of you that are joining us from Canada, they have a live implementation with Loblaws, right, in the Toronto area. Right, so without further ado, we will bring Mark up on stage. And 3, 2, 1. There he is. Mark, you're on mute. It's the video conference curse. Bottom of your screen, I think. Oh. Anyway, a reminder again that if you have panel questions, right, there are some pre-prepared questions, but if you have panel questions for the panel, please field them in the chat, right, and our team will manage them and pass them through to Mark so he can get them through to the team. How are we doing there, Mark? Oh. Looks like we have a browser issue where browser's blocking the audio. In the meantime, I'll remind you a little bit about what follows this afterwards. So after the panel session, we have a networking opportunity where the stage environment changes. You're asked to leave the stage, and your video feed gets exposed, and you can network with other members of the audience and with some of the presenters that have stayed around after their presentations. So I encourage you to do that. Please spend the time, meet each other virtually as best possible, and do some networking opportunities. See who you all are. I think there's a couple hundred of you in the audience or so, which is great for us. And if there are any other questions in the meantime, right, please put them in chat. Oh, there's Mark, and this time I don't see a mute.
Can you guys hear me?
I can hear you.
Oh, great. That's very strange. I guess there was technical issues with the previous presenter. I'm sorry about that, guys.
Mark, thank you for joining what was literally last minute, so much appreciated. Right, and you and I didn't get a chance to practice, so if I didn't get the pronunciation of your last name correct, please accept my apologies.
It was very well done. Petrosoniak.
Very good, thank you. All right, without further ado, I will hand it over to Mark and to introduce our panel and our panel session for today.
Great, thanks, Richard. Yeah, so just quick introduction. My name is Mark Petrosoniak. I'm Toronto-based. My role is, Richard mentioned, Senior Manager of Strategy and Business Operations at GADIC. We're an autonomous vehicle company for B2B short-haul logistics. I support on the strategic initiative side of things, partnerships, business development, and business operations related items. I spent 10 years at Accenture in management consulting, where I focus predominantly on supply chain, working with clients across retail, CPG, and industrial manufacturing. What I'd like to do is spend a few minutes just introducing the panel. So I'll pass it off to why don't we start with Wayne? And Wayne, why don't you introduce yourself, and then we'll jump into the questions.
Looks like I'm having the same issue with no camera. Oh, then there we go. Just different. I had the different camera. I had a web monitor I put in the other day. Apologize. My name is Wayne Scott. I work for Loblaws. I've been there since 2007. I've been in this industry now probably going on about 35 years. Starting back at the Freightliner dealership as a mechanic, and then working my way through the industry, managing fleets predominantly, and then in the last 7 years I've been at Loblaws taking care of the maintenance and procurement and innovation throughout the fleet, the over-the-road fleet. So we've been doing this a long time.
All right, thanks, Wayne. Appreciate that introduction. Why don't we hand it off to Sadie to introduce herself.
Thank you, Mark, and thanks for inviting me. Yeah, good morning, everyone. It's good morning. My name is Saida Razavi, and I'm the director of McMaster Institute for Transportation and Logistics, or MITL. I'm also an associate professor at the Department of Civil Engineering and a chair in heavy construction at McMaster University. I come from a multidisciplinary background with formal education in computer engineering with a bachelor degree, a master's degree in artificial intelligence, and a PhD degree in civil engineering. Over the last 15 years, I've worked on projects on smart mobility, smart infrastructure, construction, and supply chain. Back to you, Mark.
Thanks, Sadie. Appreciate it. And our other panelist, Khalil, can you please introduce yourself?
My name is Khalil. I'm the manager of business and development at Purolator. As you know, Purolator is part of the Canada Portfolio Company. In reality, I joined Purolator from 23 years ago, and mostly working on enterprise projects regarding IT, finance, and in 2014, I decided to launch the first R&D department at Purolator. Why? Because we need to introduce new innovative solutions for our supply chain. Purolator is, let me say, seeing a lot of growth from the last at least 10 years, and due to the fact that we are the biggest network across Canada, means that we need to be also the leader in terms of innovation for Courier Express company. In terms of background, I used to work as a consultant for the World Bank in Africa. So far, I'm continuing to work as an external consultant, but I'm graduated in Master in Business Administration from UQAM in Montreal with a specialty in logistics and transportation. Thank you.
Great, thanks. Thanks, guys, and appreciate you guys joining today out of your busy day. We're here to talk about the movement of goods and transition to autonomous operations. So as everyone likely is on the calls knows, it's a very exciting time right now where we're seeing consumer expectations changing from 1 to 2 day deliveries to same day deliveries. We're seeing a massive increase in e-commerce. Networks are changing at a rapid rate where hubs are moving closer to the consumers. And we're seeing that impacts on the retail network, CPG networks, et cetera. And we're also seeing new types of fulfillment. So for example, micro fulfillment centers, e-commerce fulfillment centers, customer fulfillment centers, all these different types of names that people are coming up with. But at the end of the day, it's getting those hubs closer to the end consumer for improved service levels. So, it's an exciting time for the industry, and we're seeing, more and more automation of transportation networks, like we've seen in the past decade, where we saw warehousing automation really ramp up. So the scope of the discussion today is really to look at the trends of anything autonomous logistics related, talking about the trends and technologies, talking about the implications on labor, as well as the implications for government and the societal impacts as well. So let's jump into it. My first question is around the trends and technology side of things. So I'll go around the panel and ask each one of you guys this question. But let's start with Wayne. What trends and technologies have initiated the transformation of?
And could you speak to some of the primary autonomous use cases and shine a light, push these to the forefront?
Thanks. It's a good question. I think what we've seen in the last few years is, a lot of this was in test cases a few years back. And if you take a look now, you can actually see where it's come to fruition. We take a look at the project that we're doing with yourselves. 3 years ago, we did another one. Didn't work out as well. So we've had a lot of learnings in the last few years. The organic project that we've got now with you, I mean, we've got our first one on, out there. We've got 4 more, looking at other class of vehicles as well. And I think that's only going to get larger and larger. The last presenter, he came up on, the small delivery vehicles for urban downtown centers, colleges, universities, so on and so forth. I think you can see that trend go, more as, people, through this pandemic have turned around and transferred more online than they've done any other time. I mean, it's been a 2 and 3x growth in the last 12 months. So I think that's really pushed along a lot of this autonomous technology. In the next few years, I see the level 4 growing, of course. Level 5, we're still 10 years out minimum, I believe, on that. Just from what I've seen from different companies and different people that I've talked to around. But I think the B2B, the short haul, final mile, still looking for a Class 8 vehicle that we can pilot up in Canada. Not too many of them around right now. But I also do believe that it will be there shortly. We're still looking at that as well. But I think that's where level 4, B2B, short haul technology is going in the next few years.
Great, thanks, Wayne. And same question to you, Sadie, around the trends and technologies that you're seeing in this space.
I would like to actually start with some of the most recent trends and technologies. We know that with recent disruptions of COVID, or let's say the pandemic, we're facing more trade-offs between supply chain cost efficiency and globalization for resiliency, reliability, and agility. So this new momentum has accelerated changes in technology, consumer behavior, and policy, which is a good thing for all of us that we're working on this smart or intelligent mobility or supply chain of the future. This acceleration was to respond to the continuous uncertainty in supply chain and demand and it resulted in more digitization, automation, and decarbonization, and also more intelligence. And these changes are likely to stay with us in the post-pandemic world. So they're not going to go away. So let's just start with saying that, for example, we have cities that have recently developed new mobility regulations and priorities that they're not going to go away that easily. For example, more than 150 cities around the world have restricted access to private vehicles and then also have changed their transportation infrastructure and redefined them to include bike lanes or more active transportation opportunities. We know that European Union leaders just recently raised the CO2 reduction target from 40% to 55% in 2030. And we've heard that California will ban the sale of new passengers cars and pickup trucks with internal combustion engine by 2035. So these are all disruptors that were accelerated recently just because of the disruptor we faced, which was the COVID-19 pandemic. Another wave of accelerated change comes from the consumer behavior. By the raising expectations and limitless purchasing opportunities, and also increasingly turning into digital channels, consumers are drivers for these changes. So other nodes of supply chain, such as retailers, manufacturers, third-party logistics companies, and others, have to catch up by producing more and in a shorter turnaround and by improving visibility and transparency. We will also see more autonomous vehicles moving goods. We saw in Corey's presentation earlier today, robots and drones in factories and warehouses, sensors and actuators to maintain inventory management, heating, lighting, and intelligence to support the planning and control of our supply chain. An example is Amazon's patented system for shipping demand. Amazon literally ships goods before we even purchase them. By predicting or having the intelligence to predict supply and demand in advance, they enable themselves to ship goods to customers in a shorter time and in lower cost. And but I don't take that much of your time, but just it's worth maybe to mention some examples of autonomous mobility are not limited to just autonomous cars. We have autonomous, obviously mobile robots, drones in warehouses. We have store robots that aid in replenishment. We have autonomous long-haul trucks and last-mile delivery trucks. But we also have autonomous freight trains and autonomous cargo ships, which maybe are considered the latest in the pool. Thank you. Back to you, Mark.
Great insights, Sadie. Appreciate that, and I'm sure the audience did too. Over to you, Khalil, to talk about this, the trends and technologies that you're seeing and what you think we're looking to in the future.
In reality, the autonomous vehicle or this type of solution will help us in two areas, especially for our industry. The first one is the shortage in terms of drivers, because so far we have a very huge issue to recruit people in order to drive our trucks, especially during the peak season. And doing the autonomous delivery will help a lot, and even the robots to assist even our, for example, food courier drivers. This is exactly what we are testing in Montreal, and we'll be testing very shortly in Toronto. It will increase our productivity, but in the same time, it will reduce the pressure in terms of driver availability. The other aspect is the safety and security aspect. The safety aspect, for example, if I take the new hub we are constructing now in Toronto, we are talking about 403,000 square feet, and with many, let we say, people working there. We are talking about maybe 1,000 people working there, with all the jiggers, with all these, let we say, movement of freight inside these type of, let we say, facilities, will increase our exposure to a lot of safety concern, and autonomous vehicle can help reducing this type of, let we say, exposure and risk for our operation. Regarding the costs, we did study with the University of Toronto, for example, by using one of the shopping centers, and we complement, if you want, our delivery driver there with an autonomous, let we say, delivery system. Guess what? That we reached the same, let we say, saving as Corey is indicating on his presentation. We're talking about 30 to 40% saving. Saving is very important. Why? Because with the COVID pressure, what we saw a balance, a complete balance. That means we had exactly 100 degrees change. For example, Purolator in March, we are doing more B2B than B2C. 80% of our freight movement is B2B. When we start closing and doing all that COVID restrictions, we turn from 20% B2C to 80% B2C. That means is a huge change for us. Huge change. We cannot, let we say, deal with it with the current, let we say, supply chain built for B2B with all the costs. You know, when we are talking about e-commerce, the margin is very thin. That's why if the autonomous robot can help us to reduce this type of cost, this is exactly where I think most of the Courier Express company are going to. In order to reduce, we need to use this type of solution. But this is the two, in reality, or three main areas where I see the future trend in terms of using more this type of solution.
Great. Thanks. And I know you mentioned this, or you kind of hit on this answer, in your first one, but I wanted to talk a little bit about the labor implications, and we'll start with you, Khalil. But what does the migration of labor-based services to autonomous operations look like? And if you can share your thoughts on specific impacts that you've seen or that you expect to see, and interested to hear your thoughts, either on the micro level that we're seeing in Ontario, or even, at a more macro level, for example, at North America or global scale.
In reality, for the labor impact and the labor-based service to autonomous operation, we need to keep in mind that many of our organizations are unionized organizations. For example, here, in the context of Purolator, we cannot move. It's not very easy move from, let we say, labor-based to autonomous, let we say, operation without the approval or agreement of our, let we say, union. I don't see it, or I don't see that move to happen very quickly. It will be by phase, or it will be progressive. Why? Because we need to understand first where to implement this type of autonomous activity. And most of the autonomous activity will really replace some repetitive, let we say, activity. Second thing, where, for example, there is no need in terms of manpower, or, for example, there is no availability of the manpower. We talk about drivers, for example, for in our sector. But to be honest with you, I see autonomous activity as a complement for what we have so far, due to the fact that the way that the labor is organized in Canada and North America, it will be a lot of roadblocks before, for example, company like Purolator to move to full autonomous, for example, parcel delivery or last mile delivery. It's the case everywhere, I think, in North America. If you take UPS is unionized. FedEx, part of the FedEx is unionized. I'm talking about our industry. The same thing for Canada Post. I want to give you just an example. For example, in Europe, they tried to introduce the Follow Me robot to assist and help their mail people, and the union refused to introduce that. That's why the migration from labor-based to autonomous operation need to take into consideration the labor condition, the labor legislation, but also it need to be introduced as a complement for what the organization are doing.
Great, thanks for that. Over to you, Sadie, on what you're seeing from a labor impacts or labor implications and relating to autonomy.
We kind of discussed that autonomous vehicles, robots, AI, machine learning are the key enablers of our future supply chain, or better to call it our autonomous supply chain of the future. It's important to note that these disruptions are happening at a larger scale and faster pace than the human can easily adapt with. And this is a study proven that human adoption rate is slower than what the technology is happening right now. So it's only natural to fear these disruptors and be worried if people will be displaced out of work because of automation. That's one of the main concerns when it comes to the workforce of the future and autonomy. So to calm this fear, let me just encourage people to think back in 1850s when Otis, you know that name through all the elevators probably, right? Otis introduced safety elevator in 1850s. After that, that widespread fear about using elevators are too dangerous went away. So then we had the acceptance of vertical transportation. And later on in 1894, I believe, they started the first autonomous or driver-operated or driverless elevator which might be the first instance of autonomous vehicle around in the history. So what Otis, in fact, helped was created was to help societies to reach higher elevation in city development and growth. So these driverless elevators displaced the work of operators, but created work in many other areas, such as electrical and mechanical manufacturing and support for elevators. But way much beyond that, they created job and opportunities in other sectors, such as construction, real estate, city building, city planning, and they created significant socioeconomical impact by allowing cities to develop and grow. So here we are. When we think about the future of supply chain being autonomous, let's remind ourselves about the workforce that were displaced, but then what happened, all the opportunities happened. So the same as many others, I also believe that the future of goods or goods movement will have a low degree of human intervention. But in this shift, the nature of work will be replaced. The people will not. So in the future supply chain environment, employees are less encumbered with unsafe and repetitive tasks and will have more opportunities to contribute to innovation and decision making. And that's the beauty of the future in that autonomous environment. They will need to be integrated and will be required to have a wide breadth of knowledge and skills to contribute to decision making, as opposed to the traditional deep skill sets in a particular area and lack of ability for making decisions. Another important capability needed for the future workforce, and what is needed for us to keep us ready for the future, is that we need to have, the future workforce need to have high ability to adapt and thrive in an environment of change. We have faced it today. Lots of changes from our moderator, and Mark just showed agility and high adaptability to just step in and take this opportunity to all those technical challenges. And this is what we're going to see. So we need a lot of high adaptability quotient, or AQ, for our future workforce. I think I'll stop here. Mark, back to you.
All right, thanks, Sadie. That's just for the sake of time. I'll pass it off to Wayne to address the labor question and what the implications of that of autonomous operations has on that the future of the workforce.
Great, thank you. There's a substantial shortage of drivers in the workforce right now, regardless. I mean, if you take a look at Canada, the baby boomer population is coming out. People are not getting back into that driver role, that long haul driver role, or the short haul. They want to be home every day. People are changing the way they want to do and react. When I started in this industry, it wasn't uncommon for somebody to get in a truck and go away for 2-3 weeks at a time and come home for a weekend and leave again. People want better time, work family balance. They want to be home every night. So I think that as Sita said, as people are coming in, as this technology comes up on an S curve, I think what you're going to see is, as the drivers now are getting out of the industry, this will take over a little bit of the industry, and then as that S curve hits the top, regardless of what year that's going to be, we'll have to adapt depending on the rate of change and technology and how people will actually accept the change. I mean, if you take a look at with you, Mark, with Gatik, I mean, our vehicle will be driverless come later this year on public streets. I'm just waiting for the first phone call on how we're going to address that as this drives down Steeles Avenue. And the adaptive change, I think, is going to be, based on that. Are we going to get kickback? Are we going to get, are people going to come back? Are people going to try to hit the vehicle just to see if they can? Will it stop? I think people are a little apprehensive about the technology right now. If you read any of the studies that I've seen, 70 to 75% of people still are reluctant to get into a fully autonomous vehicle, let alone seeing an autonomous Class 8 drive down the road at 80,000 pounds. There's a couple books, an author, Tony Seba, not too sure if you've heard of him before, but he does transportation disruption, S curves, and the whole bit. And one of his presentations, he had the picture of 1905. I think it was New York City, and there was all horse and buggy and one car. 10 years later, it's a great picture, same corner, same everything, all cars, one horse and buggy. You know, as New York grew, I mean, there's no horse and buggies anymore. Like, you know, he's probably a tourist. But if you take a look at that, you know, they were able to change, adapt, repurpose labor, you know, so on and so forth. You know, there's no horse and buggy, there's not a blacksmith on every corner anymore. So we've evolved, we've changed, you know, people have gone from blacksmiths, buggy makers to cars, you know, they've adapted and moved on to other businesses. So I think it's a few years out, but I think as drivers leave this industry and that baby boomer population, people don't want to get back into it. I think that, you know, it's a good bend in that S curve where some of this will take over from B2B and short haul.
Great, thanks guys for those answers to the question. One thing I do want to do, just to remind the audience members, is to type in any questions that you have into the chat. We'll try to save a bit of time at the end. I'll get into one more question for the panelists, but please do share any questions that you have as we go. So I guess over to you, Wayne, again, around the government policy. So what role do you think governments can play in fostering advancements in autonomous technologies and operations?
Well, I know that I think it was 2009, I believe it was, Ontario turned around and put a 10-year plan out. I think they revised it several times since. As car manufacturers turn around and have level 3 on the road right now, people start getting used to it, whether it be the Teslas, anybody else in that model. Even in the Class 8 trucks right now, you know, you can buy a Daimler-Benz or a Freightliner Western Star truck at level 3. So I think if people get more accustomed to that, I think, and governments get used to it, they're a little slower to change than I think than what the industry will. But I think that as some very large companies turn around and, you know, Alphabet, Google, everyone else, Tesla, as they start ramping this up, I think you'll see states that want this technology in their state, and they're going to change legislation faster than others. And I think you're going to get some that'll be very slow with it. They're reluctant to change based on their demographics, based on whatever. They might be, a couple of years behind. But I also think that states that do change it the fastest will get the biggest influx of new business, new growth. And I think that they're going to be pushed into it, but I think their constituents might just take a little bit of time.
Great, thanks, Wayne. Sadie, what role do you think governments can play in fostering advancements in autonomous operations?
First, we need to acknowledge that we cannot be future ready unless all levels of government work together and work together effectively. Governments also will need to collaborate with industry and research enterprises to create different design and operational guidelines and policies. These changes, or the role of government, can be summarized in the areas of roadway and transportation infrastructure, communication and digital infrastructure, data management, governance and standards, as well as consumer behavior and adaptation. So, which means we need to bring more public awareness and education to the public and engaging them in the process, which is very critical. But more importantly, the future of supply chain landscape will need skill sets related to new technologies and data analytics and new platforms, among others. So educating the new generation of skilled workers and professionals with the right set of skill sets will be the key for future success for our competitiveness, which governments need to be involved in that. So I just to wrap it up with saying that Canada has taken some really good steps for now so far for being future ready for mobility landscape, such as a program such as this. Even we have MTO's CAV readiness plan and Transport Canada's ACAT program. However, I believe we need wider engagement, funding, and visibility, as well as some investment in some curriculum planning or micro-credential planning for more improvement in the state of the future readiness for Canada.
Great. Khalil, any thoughts on this?
In reality, I echo the two comments from Wayne and from Sadiq, because in reality, when we are talking about the autonomous, yes, we need to talk about legislation. Legislation is very important, and the most important thing, we don't want to see what's happening in electric vehicle. For example, we have federal legislation, and we have for each province has the freedom to do their own restriction and their own legislation. We need to have a standard legislation across the board, correct? So it will facilitate a lot the progress and the introduction of this, let me say, type of solution. Second thing, very important also, is the risk management. Risk management and sharing, because when he's talking about vehicle inside the street, okay, if we put autonomous, let me say, delivery robots inside the street, there is a risk, and that risk need to be shared with the, let me say, local authorities, but also with the organization using that type of, let me say, vehicle. I take as an example, for example, I think there is a problem last year with Starship with pedestrian, and it's creating a lot of problems. There is a lot of complaint from customers. That type of, let me say, risk need to be really well studied especially by academia, and for to educate the government when they are doing the legislation, and to ensure a good liability, let me say, program in order for us as a company to use the street and put autonomous vehicle on the street. The second element, I think Sadia mentioned it, is the infrastructure. Why infrastructure? Because when you put autonomous vehicle, think about the weather, think about the condition of the streets. We are launching electric e-bikes or cargo e-bikes, and we have a lot of problem with the quality of our streets. How about now we are putting autonomous robots? Cities need to be involved in terms of physical instruction, that means the roads and the streets, but in the same time, if we are using robot for let me say outdoor delivery, indoor delivery, there is no problem for the autonomous robots. Very easy, very straightforward, let me say, usage of this type of technology. But for the indoor, for the outdoor, we have problem. Also, the smart cities, we need to have access to these smart cities in order for us also to use this type of technology. The last one, it's very important, and I'm taking the analogy with the electric vehicle, is the fact that when we talk about autonomous, yes, in some cases they are not very costly, but for example, when we use autonomous vehicle for example, like a tractor, autonomous line haul, or for example, to move our trailer inside the yard, like what Corey showed in the port, we have the same type of, let me say, usage in our yard to move these semi-trailers and to position them on the dock doors. This type of technology is very costly. If the government cannot help us with some subsidies, we cannot have access to this type of technology. That means the role of the government, especially in Canada, will remain very important to introduce this type of technology, and especially for us as a user to use them for our day-to-day activity.
Great. Thanks, guys. Maybe just another question that has come up from the audience is around, as we think about the evolution of autonomous operations, are there any early wins or any type of early wins around the return on investments that we can see or expect to see in the autonomous operations field before we go fully autonomous? Maybe Sadie, do you want to comment?
I would like to pass.
Okay.
Nothing comes to my mind other than saying that the early wins may not necessarily be in the economic aspect of things. It might be in the safety or intelligence that these systems will bring to the. So it's an investment for future.
Yeah, that's a fair point. So maybe it's not if you're not taking the economic value approach, maybe there's a safety side of it which translates indirectly to savings in other ways. Maybe Wayne, do you have any thoughts on this early wins as we kind of progress up that S curve that you mentioned earlier in the autonomous operations side of things?
The one thing we can take a look at right now is there's no return on investment on an autonomous vehicle right now. The costs are great. We've still got drivers behind the wheels, and don't get me wrong, it's going to be years before we ever get to a point where we can allow these things to drive down the road. I think we'll get there. When that will be, I'm not sure. I think as far as the safety aspect of it, if you take a look at just that in itself, and that S curve that we talked about a little earlier, if you think that cars have been around for 120 years, and for the first 100, there really wasn't much improvement. You might have cruise control in the early 70s, but in the last 20 years, I mean, you've got lane avoidance, you've got roll stability, you've got cruise control, you've got lane centering, you've got self-piloting, you've got lane keep. And considering that 94% of all accidents, based on NHTSA's, it's easy to get some of the numbers out of the NHTSA out of the U.S. than it is out of Canada. But if all accidents are driver, 94% of them have been deemed to be driver behavior. You take a look at some of the cars you've got now. As far as my wife's new car, and it's just a little Mazda CX-5, and it takes the ability away. You can't rear end anybody anymore. It stops you. And if you do rear end somebody, the ability to have the damage or the personal injury is considerably less. And I think those are the quick wins as this technology, rolls out in that S curve. Just look at your personal car. 20 years, it's come a long way.
Great. Any thoughts on this, Khalil, in 10 seconds, and then I'll progress to the question.
In reality, there is two aspects. The first one is to go back to Wayne, is health and safety. Because, for example, if we put more delivery robots on the street, we will be reducing the exposure of our driver to injuries. And most of our injuries in terms of, let me say, deliveries coming from our driver, correct? Second element, very important, is the CO2 emission, because more autonomous delivery means what? Means less trucks or fuel trucks on the street. These two elements are very important for us, and there is for sure there is a cost associated to it, if it's in terms of CO2 emission or in terms of health and safety. Health and safety, for example, aspect it's cost us around $17 million per year in terms of accident and injuries. In addition, the fact that the driver will not be available for the next day delivery. Now, autonomous delivery will play a big role in that part. And to go back to the question about the return on investment, yes, there is no a lot of study to indicate that, but I'm more than confident that if the autonomous solution will be put in the right context, for sure we will see a very good and interesting return on investment.
Great, thanks. Sadie, over to you on what are some of the most dramatic societal impacts and shifts that we expect to see as a result of the shift from labor-based to autonomous operations?
I kind of alluded into that the future workforce will be will be away from mundane, repetitive, dangerous tasks. So we are increasing safety, we are increasing improvement, efficiency, but not just on the labor side, but on the business side. That means the businesses will be faster in delivering fulfillment and will be more efficient, will have higher profit, obviously at a cost of more capital investment and investment on their labor. I just want to emphasize that one of the main, the most dramatic shifts that I see, or the most dramatic societal impact that I see, is in the lies on human, or people who are going to be involved, and the way that the workforce is going to be shifted, and the type of work and activities that's going to happen in the future in this domain.
Great. Wayne, any final thoughts, and do you want to chime in on the society, the types of impacts that we can expect from a society in general?
You know, I think it's going to take a long time for this to get to fruition. I think what we're doing right now is we're seeing where we're doing the pilots with you, and we've got some other stuff in the works as well. But you know, people are changing, and industry's changing, and you know, we as a company has to keep up with it.
Khalil, any final thoughts, and what are your thoughts around the societal impacts of moving toward autonomous operations?
The social impact, it will be especially in terms of city development, because so far, if we take the example of City of Toronto, based on the new plans and the current plans and the future plan, first thing, we know that within the next few years, 3 of 5 residents will be located in cities. Means what? Means, for example, if I take again that example of Toronto, you will have a lot of high rising, and this is exactly what's happening now with all these high rising. I saw last 2 weeks a plan, future plan for Toronto. It will be a big concern for us. Why? Because most of the time we are trying to keep our product and service, and even the same thing for example, grocery stores and retail, to keep their service and product near the customer. And here, autonomous will play that type of role. For example, for high rising, by using Starshift or some that type of, let we say, technology, we can ease the type of, let we say, needs from the customer to have the product near, let we say, their location. For example, you have a robot to deliver to a high rising, and on the parking lot, in the underground, we can create fulfillment center, and from that fulfillment center, we can, for example, deliver products, if it's grocery, if it's retail, if it's clothes, anything to that tower, let we say, that rising building. This type of, let we say, change in our cities, for sure we will see more need in terms of autonomous solution, for the simple reason that our drivers or our people cannot move now in the future in this type of new cities and new design of this. There is a huge impact of the autonomous, let we say, technology in the way even people will be living, or it will be, I can say, the reverse, in the way that people will be living will have a new impact on the autonomous solution. The impact will be positive in the fact that we will see a lot of increase in terms of usage of that type of solution in the near future, especially in mega cities like Toronto, Montreal, Vancouver, and so.
Great. Okay, I would like to take this opportunity to thank our panelists today to facilitate this discussion on movement of goods and the transition to autonomous operations. So thank you for sharing all your insights. Super interesting. I'd also like to thank the audience for listening in and asking a few questions. I'll pass it off to Richard, and thanks again.
All right. Thanks very much, Mark. And again, thanks for joining us at kind of the 11th hour at this. So just check, can you hear me? Okay, good. And so, first of all, thank you to our panel members, Wayne, Khalil, and Saida, as well as Mark. Very interesting discussions, some pretty tough questions. We didn't get to all the questions in the audience for time. We'll do our best to provide some sort of answer to those afterwards. I wanted to just go through a couple of housekeeping notes for today. For tomorrow, we have presentations, a keynote from Parabellix, a presentation from Innovex, right, and a panel discussion on cybersecurity. And I know certainly in the Arrigo presentation, there were lots of questions on security of the vehicles and securing that. So a double click and a deeper dive on that for tomorrow. Thank you to all of you for attending and your questions and your engagement today. Just a quick reminder that this event is a joint presentation of the Innovation Factory in Hamilton, the Centre for Integrated Transportation and Mobility, the Ontario Tech University, Spark Centre in Oshawa, Durham College, and most of all, the Ontario's Autonomous Vehicle Innovation Network, of which Oshawa and Durham are a part of. If you missed any of the presentations or segments, they will eventually be available on CITM's website. Right, so give us a couple of days to process, and they will be up there. I'll check the website, the event website, for the schedule for tomorrow and any timing issues. And then, without further ado, then I encourage you all to hang around and participate in the networking section. The stage, you're all at the main stage now. The presentation of the stage will change. You'll be invited to network, right? And it's your opportunity to integrate with the audience and ask a few questions. I'll be there. I'm not sure how many panel members are hanging around. But again, please do join us for networking. So with that, thank you very much for day one. I look forward to seeing you all again tomorrow. And thanks again. Have a great rest of your day.